In 1977, humanity launched 2 machines into the darkness, and they never truly came back. They traveled beyond the worlds we thought we understood, past the rings we assumed were simple, and past moons we once considered little more than frozen rocks. With every image they sent home, the solar system became stranger, more dynamic, and far more alive than anyone had imagined. Voyager 1 and Voyager 2 were more than spacecraft. They became humanity's eyes in the outer solar system, revealing giant storms, erupting moons, intricate rings, fractured ice worlds, and eventually the astonishing fragility of Earth itself. Before Voyager, the outer planets were distant objects seen mostly through telescopes. Scientists had models and theories, but they lacked something essential: close-up evidence. We did not know how these worlds behaved up close, what their atmospheres were really like, or whether their moons were geologically active. Voyager was about to change that forever. The story began with a rare opportunity. During the late 1970s, Jupiter, Saturn, Uranus, and Neptune were positioned in a configuration that allowed a spacecraft to use gravity assists to travel from one giant planet to the next. This alignment occurs roughly once every 176 years, giving NASA a chance to attempt something that would otherwise have been extraordinarily difficult. Voyager 2 launched on August 20, 1977, followed by Voyager 1 on September 5. Although Voyager 2 launched first, Voyager 1 was placed on a faster trajectory and eventually overtook its twin. Even before reaching the planets, the spacecraft gave humanity a new perspective. Voyager 1 looked back toward Earth and the Moon shortly after launch, capturing them together from millions of kilometers away. It was an early reminder that this enormous journey had begun from one tiny world. Then came Jupiter. Voyager 1 reached the giant planet in March 1979, with Voyager 2 following several months later. What they saw transformed Jupiter from a distant striped sphere into a world of enormous turbulence and constant motion. The Great Red Spot revealed itself as a gigantic rotating storm, while the atmosphere around it displayed layers of clouds, powerful currents, plumes, and intricate patterns. Jupiter was not a static planet. It was a constantly changing atmosphere on a colossal scale. But Jupiter itself was not the biggest surprise. That honor went to Io. Scientists had expected Io to resemble a heavily cratered, relatively quiet moon. Instead, Voyager discovered active volcanoes erupting across its surface, with enormous plumes of material rising hundreds of kilometers into space. Lava-filled regions and rapidly changing terrain revealed that Io was one of the most volcanically active worlds in the solar system. It was the first time active volcanic activity had been observed on another world. Then Voyager looked at Europa. Its surface was covered with long fractures and strange patterns that suggested powerful forces were operating beneath the ice. The observations helped establish Europa as one of the most intriguing places in the solar system and eventually contributed to the modern idea that a vast ocean could exist beneath its frozen crust. In a single planetary system, Voyager had revealed a volcanic world and an icy moon that might hide an ocean. The outer solar system no longer looked dead. Then came Saturn. From Earth, Saturn had always appeared almost impossibly elegant, surrounded by a few broad, clean-looking rings. Voyager revealed something much more complicated. The rings contained countless narrow ringlets, gaps, waves, kinks, and delicate structures. The spacecraft also discovered additional rings and provided evidence of small moons influencing the material around them. Saturn's rings were not simple bands. They were an extraordinarily complex system governed by gravity, collisions, and interactions with tiny moons. The moons were just as surprising. Triton emerged as a world surrounded by a thick nitrogen-rich atmosphere, making it fundamentally different from the airless moons scientists had expected to find around the outer planets. Enceladus also showed signs that it was not simply a frozen ball of ice. Later missions would reveal its remarkable activity in much greater detail, including jets of material escaping from its surface. Voyager was beginning to change the definition of a moon. These were not just objects orbiting planets. They were worlds with geology, chemistry, atmospheres, and histories of their own. After Saturn, Voyager 1 followed a trajectory that carried it away from the main planetary plane and toward the outer reaches of the solar system. Voyager 2 continued the journey. In 1986, it reached Uranus. Uranus initially appeared almost featureless compared with Jupiter and Saturn. But beneath that seemingly calm appearance was one of the strangest planetary systems ever encountered. The planet rotates with an extreme axial tilt, essentially rolling around the Sun on its side. Its magnetic field is also dramatically offset and tilted relative to its rotation, producing a magnetosphere unlike those previously encountered. Voyager 2 discovered additional moons and rings and revealed strange geological features across several icy satellites. One of the most remarkable was Miranda. Its surface looked almost shattered and reconstructed, with enormous cliffs, grooves, and contrasting regions that suggested a complicated geological past. It was a reminder that even a relatively small moon could possess an extraordinary history. Then, in 1989, Voyager 2 reached Neptune, completing humanity's first and only close-up tour of all 4 giant planets. At the edge of the planetary system, scientists expected a cold and quiet world. Instead, they found another planet full of motion. Neptune possessed incredibly powerful winds and enormous atmospheric storms. Voyager observed the Great Dark Spot, a massive storm system that stood out against the planet's deep blue atmosphere. Its rings were also more complicated than expected, including incomplete-looking arcs and dusty structures that raised questions about how such features could remain stable. And then there was Triton. Neptune's largest moon displayed a bizarre frozen landscape, with fractured terrain and geyser-like plumes rising from its surface. Even in the extreme cold of the outer solar system, Triton appeared geologically active. By the time Voyager 2 moved away from Neptune, the grand tour was complete. But the spacecraft had delivered a much larger message. The outer solar system was not a collection of frozen, lifeless objects. It was a dynamic collection of worlds. Perhaps one of Voyager's greatest scientific legacies was changing the way we think about moons. Before the mission, moons were often treated as secondary objects orbiting more important planets. Voyager showed that this idea was completely misleading. Io was erupting. Europa had a fractured icy surface that hinted at a hidden ocean. Titan possessed a dense atmosphere unlike any other moon known at the time. Miranda displayed extraordinary geological complexity. Triton had active plumes despite existing in an environment unimaginably cold by Earth standards. The moons were not leftovers. They were worlds. And many of them became important targets for future missions precisely because Voyager showed us how much was hiding there. But after revealing the giant planets and their moons, Voyager produced another discovery that was far more personal. It looked back toward home. From the outer solar system, Voyager 1 turned its camera toward Earth and captured a tiny point of light suspended within a scattered beam of sunlight. The image became known as the pale blue dot. Earth appeared almost impossibly small. Everything humanity had ever built, every civilization, every conflict, every friendship, every generation, existed on that tiny world. The image changed the meaning of the mission. Voyager was no longer only showing us what existed beyond Earth. It was showing us our place within it. The spacecraft had traveled past enormous storms, volcanic landscapes, icy moons, and distant planets, only to reveal that the world we call home was itself incredibly small and fragile. And the journey still wasn't over. After the planetary encounters ended, both Voyagers continued outward. The sun's influence gradually weakened. The solar wind changed. The environment became increasingly different from the space near Earth. Eventually, the spacecraft crossed the heliosphere and entered interstellar space. Voyager 1 crossed the heliopause in 2012, while Voyager 2 followed in 2018. For the first time, human-built spacecraft were directly sampling the space between the stars. The Voyagers had transformed from planetary explorers into interstellar pioneers. And perhaps the most remarkable part is that these machines were designed in an era when computers were primitive compared with today's technology. They were launched decades before smartphones, modern GPS systems, and the internet became part of everyday life. Yet they continued sending scientific information across billions of kilometers. Each spacecraft also carries something far more symbolic than scientific instruments. The Golden Record. Attached to each Voyager is a gold-plated record containing sounds, images, greetings, music, and information about Earth and humanity. It was never realistically expected to be discovered by another civilization anytime soon. That was not really the point. The record represents an idea. Humanity knew almost nothing about what waited beyond the planets, yet we still chose to send a message. A small introduction from one distant world to an unknown universe. The Voyagers were built to explore. But over time, they became messengers.